Hi everyone, my name is Hassan. Thank you for joining me today. I'm excited to introduce you support vector regression, specifically by implementing these algorithms in MATLAB with a practical data basis. So, um, SVR is a robust and versatile algorithm in machine learning. SVR is particularly well designed for curve fitting and regression and prediction tasks. And also you can use it for forecasting, I mean uh, time series data, but it doesn't uh, handle the time series data directly. At first, it requires to convert the time series data to a feature matrix or extracting feature from time series data and then use SVR for that specific data type. And we have SVM, which you might already knows as a powerful classification algorithm, support vector machines, SVM. At first we had SVM, I mean SVM was produced before SVR. So SVR is specific for classification, for uh, discrimination, and SVR is designed for regression, support vector regression. Um, this algorithm is one of the powerful tools in machine learning, but it isn't only option for regression in machine learning. We have many algorithms to regression for regression. What are the other algorithms? What are the other options? I listed here. The first row of the first category refers to machine learning algorithms, GPR, Gaussian process regression, linear regression, multilayer perceptron, or radial basis function, ANFIS, fuzzy inference system, random forest, KNN, decision tree, and least square boost. And the second category refers to deep learning algorithms, LSTM, RNN, GRU, and CNN. We can use all of these algorithms for regression. Okay, so absolutely there are many options for regression, but one of the best algorithm in this area is SVR, support vector regression. I had a more than 10 years experience in coding and developing machine learning algorithms, and I can say you SVR is one of the best and powerful algorithm for regression. So you can use it, you can select it the one of your options to handle your data. And SVR has many key features. For example, it can handle high dimensional data, it can handle data within the presence of noise, it can handle give you a robust answer. It's really important to machine learning algorithms to have a robust answer. And another feature here I would like to mention it is it can handle the high nonlinearity of data by adding some specific kernel function, for example RBF or Gaussian uh, kernel function or polynomial or linear kernel function. There are three well-known kernel function, and also it's give you an opportunity to design your kernel function, your specific kernel function for handling your data with more accuracy. I mean, you can design your specific kernel function for your specific data. Implementing SVR in MATLAB. MATLAB provides an excellent environment for machine learning and deep learning algorithms, thanks to its built-in libraries and intuitive syntax. Well, let's start with the first step. We have many steps here, actually 1, 2, 3, 4, 5, 6 and 7 steps for implementing the SVR in MATLAB. The first step is refers to loading data. There are many options to load your data from different format files, for example .scv files, Excel files, .mat files. You can use read matrix or import data. You can use interchangeably for loading your data with different types in MATLAB. And for example, we can run and load our data. It's a simple data with 3 features and 1 output. So you should load your data in this format, in this syntax. Features contain the columns of your matrix, and the last column is refers to the output or target of your data. So these 3 columns are the features, and the last column is the target. So we can separate the targets and features in this way. We have features and targets. 3 features in 201 samples. And the next step is dividing the data into training and testing data. And again, there are many options to divide or split your data into training and testing. One of the best way is cross-validation partitioning. We should use the number of samples as a first input, and the method of partitioning holdout with the rate of 0.3. It means 30% of data is for testing and the others for training. 30% for training and 70% for training and 30% for testing. Okay, we can separate in this way the testing data, training data and testing data within their targets. And the next step is really important, but here I have to ignore it. This step is really important when you can't receive uh, the desired output, the desired accuracy of your implementation of your data. For example, you can reach a poor RMS. You reach a poor RMSE or regression value. There are many options I listed here to use to improve your accuracy. For example, some preprocessing such as standardize, normalize, handling missing values, outlier detection. All of them are preprocessing algorithm to improve that which can help you to improve your accuracy. And mapping your data, like SVR can give can take different type of kernels like Gaussian or RBF. It's the same. You can use you can convert your data with a specific map before a training model. You can map your data in a new space, and you can design your a specific map for this work. It's really important. It can help you when you are challenging to receive a high accuracy. And beyond all of them, another preprocessing is, in my opinion, it's the best method to improve the accuracy is feature selection. There are many options: wrapper, filters, embedded. Three main categories of feature selections, and all. For example, wrapper can use meta-heuristic algorithms such as PSO, genetic algorithm, or Gray-Wolf optimizer, Veil algorithm, reptile search algorithm. There are many options in this category. It's the best category among these three categories. Wrappers usually offer you the best performance. So feature selection, the purpose of feature selection is to select the best subset of your features. So you can use wrappers methods or filter or embedded. It's on you. But it's really important, and in my opinion, that I'm a specialist in feature selection, I recommend you. Feature selection has a high ability to improve your accuracy. So I ignore this part because it takes time, and here I'm going to focus on SVR, not pre-processing steps. So the next step is train SVR model. There is a function in MATLAB. There is a MATLAB function fit RSVM. Fitting R regression SVM support vector machines. So we can use this function for SVR, and it has it takes many inputs The two first inputs are referred to training data, features and targets, and the others inputs in SVR refer to a setting hyperparameters. There are three main hyperparameters in SVR. Kernel function and its parameter kernel scale is the first and main hyperparameter in SVR. And let me add some others. Box constraints, you can set it, for example, 1. All of them are positive integer, positive value. And I guess epsilon is the third main parameter of SVR. It's usually needs to set a small value, for example. And standardize, it's a preprocessing I mentioned here. So this function give me the opportunity to standardize our data or not, true or false. Okay, but the main parameters here are these parameters. Kernel function, there are many options. There are 3 options specifically: RBF, linear, or polynomial. When we use polynomial, it's better to set another parameter, polynomial order. It's an normal number, integer number, positive and integer number. For example, 5. Okay, so these are the main parameters, hyperparameters of SVR. Here I would like to recommend you, for optimizing this parameter, use meta-heuristic algorithms such as PSO, genetic algorithm, Gray-Wolf-Weil optimization, reptile search, marine predictor algorithms, and others. There are many more than thousands meta-heuristic algorithms that you can use to optimize, to find the optimal parameters of parameters of SVR for your data. So it's really important to find the optimal parameters specifically for training your data. Okay, so it's really important, and highly recommend you to use these meta-heuristic algorithm to find an optimal value of your hyperparameter in SVR. And besides, there are other options for optimizing hyperparameters. For example, Bayesian optimization algorithm. You can use Bayesian optimization algorithm to find an optimal, but these algorithms give you a better performance. And let's go to the next step. So the training steps, we train the SVR model with training data, including features and targets. And this is the trained model of SVR. So for predicting, we only require this model and the matrix of test data, feature matrix of test data. So we can use the function predict function for predicting the testing data. SVR model as a first input and the test data feature matrix as a second input of the predict function, and as a result we have the predicted target value. So in the two last steps we have evaluating and plot the popular figures to visualization. For example, for evaluation we have MSE or rmse, two main and important metrics for evaluating the output of a regression model in general. Mean square error, this is the error, this is the square, and this is the mean square error. Okay, and rmse we can add a square, the function of sqrt in MATLAB calculate the square of a value. So we can print, after calculating MSE and rmse, we can print in the command window, and the last part we can plot regression plot of the test data or all data for better visualization, and we can plot the fitting between targets and all data. Let me run the code to show you the result, the output of our codes. Okay. See, you can see we achieve the best 100% accuracy with this design of hyperparameter in SVR in our typical databases. Okay, let me introduce these plots. This plot is referred for testing data. If you remember, we add here the first figure for testing data for plotting regression. This is the output of this part. Okay, and this is for all data, including training, both training and testing data together. And this is the real value of our target. We plot our target within SVR predicted values or on all data. Okay, you can see it's perfectly predict the output. Let me analyze the hyperparameter of SVR and let me show you the sensitivity of these parameters. For example, let me change it this one. Okay, and let me set a higher value. You can see the result changed, for example 0.5, and you can see the result is going to worse. Okay, and we set it, for example. Okay, so let's go to change the another parameters, for example دهم or bigger one, and kernel you can see kernel scale, a smaller kernel scale make it worse. Okay, and the larger kernel scale, for example 10, make it better. Or we can use another kernel function instead of polynomial, for example RBF, and we have to remove this parameter because that was specific for polynomial, and run again. Okay, set a larger one for kernel scale. Oh, you can see, make it worse, and you can see rmse and mse goes up, and so you saw these parameters can directly affect on the output in our metrics, for example MSE, RMSE, or R or R square. So you should set this parameter in an effective way, for example using multi-heuristic algorithm, or setting based on a knowledge in this case. Conclusion, support vector regression is a powerful tool in machine learning, offering flexibility, robustness, and high accuracy. It can handle high dimensional databases, data within this noise, and it requires to set some specific parameters. We saw these parameters are really important to receiving a high accuracy. And another steps that I highly recommend you to focus on it is pre-processing step, specifically feature selection. And thank you so much for following me. It is a great motivation for me to develop more courses and share my extensive experience in machine learning and deep learning.